Finding the equivalent exponential form of this particular log function means simply that I raise the base to the exponent, which will give me the argument. These three words are important. In formula form, it'll be just the base to the y, which is equal to x. And I've used colors here to help you see which one's which. And these two forms are equivalent. The real meaning of this particular form is how many times can I multiply b to get a value of x. Simply written, we just write b to the power or the exponent of y is equal to x. Now note here that I have been using x and y. And you may see it written as log to the base b, y equals x, which will now mean that it is b to the x is equal to y. To find that equivalent exponential form, you need to understand what you're doing. Because I have seen books where they use values of n and m, which translates to b to the exponent m is equal to n. Also, I have seen textbooks which used a to denote the base and followed by x is equal to b. These are all equivalent. Now, you may want to visually connect the base to the exponent this way, and that now becomes the argument. Okay, so let's just try some real examples. No variables this time, so that's just going to be 2 to the power of 5, which is equal to 32. And another example we might have to find the equivalent of this, we will say that the base is 3 and we are going up to the exponent, which was going to be 4, and that's going to be equal to 81. Okay, have you noticed that the base changes, but the base always has to be greater than 0? Okay, which means that it cannot be negative and it cannot be 0. Because 0 to the power of anything will be just 0. 0 to the power of 3, well, that's just going to be 0. Yeah, for example, if I multiply 0 times 0 times 0 3 times, all I'm going to get is 0. And also, base cannot be equal to 1. Because 1 to the power of anything will always be 1. A very common base is the base 10. So whenever we write base 10, we don't usually bother writing the 10. We just write log x equals 1. It's the same. So if the base is absent, it always means that it is 10. So let's look at an example where it's just written as log 1000 is equal to 3. We always assume that the base is going to be 10, so we will put 10 to the power of 3 is equal to 1000. And one more example of a log, which is to the power of base 5. And this looks pretty daunting, but isn't, because all it means is that 5 is now to the power of 3 on 2, which equals to 5 root 5.